Here we're going to talk about mutually exclusive and non-mutually exclusive events. So we have a simple example with playing cards. Playing cards, another thing that's used all the time with probability because most of us are really familiar with it. So consider these three events. X is that the card is a heart, Y is the card is an ace, and Z, the card is a 7. Just for those of you that don't know, and if you don't know about cards, you should probably get a deck. But there's hearts, there's diamonds, there's spades, which look something like that, and then there are clubs, which look something like that. For these called shovels, those called broccolis, but it's the basic suits. 4 suits, each suit has 13 cards, labeled ace through king. Ace is like a 1, and 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. So notice that set X and set Y, event X, event Y, have a common outcome, the ace of hearts. Ace of hearts fits into both X and Y. X and Z also have a common outcome, and that common outcome would be the 7 of hearts. The 7 of hearts is both a 7 and a heart at the same time. But Y and Z don't have any common outcomes. There are no cards that are aces and 7s at the same time. So when we talk about mutually exclusive events and non-mutually exclusive events, we'll get to the definitions in a minute, but we're talking about looking at one event and deciding if this one event can be more than one thing at a time. If two events have no common outcomes, they are mutually exclusive, or you'll hear them called disjoint events also. If two events have common outcomes, they are not mutually exclusive. So if we come back here, X and Y are not mutually exclusive. Neither are X and Z. However, Y and Z are mutually exclusive. They don't have anything in common. So let's look at the sample space for our cards. And let's look at this probability of ace or 7. Looking at our sample space, these are all the events that correspond to ace or 7. And we could say that this is simply probability of an ace plus probability of a 7. Remember, this was the situation where they're mutually exclusive. Call it ME, mutually exclusive. Now, if we shift to a heart or 7, remember we said that this event was not ME, not me. And notice what we have visually. This row of dots represents all of the cards that are hearts, and this row of dots represents all of the cards that are 7s. And notice there's this one that is overlapped in both groups. Now, if I just said, okay, I'm going to go like mutually exclusive ones and take probability of a heart, that's a heart, by the way, 2 sides, just like our hearts, plus probability of a 7, we'd have 13 out of 52 plus 4 out of 52, and that's 17 out of 52. And that's not the right probability because there are only 16 dots highlighted total. And the reason that it's not that way is we counted this one twice doing it this way. So what we do is we have to subtract the probability that this card is a heart and a 7 at the same time. We have to subtract that thing that got counted twice. We have to subtract the overlap, and that's going to get us the 16 out of 52. This is 13 out of 52 plus 4 out of 52 minus 1 out of 52. And that is what these two things summarize. Mutually exclusive events, we simply add the two probabilities. If we have an event that is not mutually exclusive, we add the two probabilities, but then we have to subtract whatever the probability is that were both things at the same time.